resulting into the formation of an intermediate RCHNH2, and this being stabilized by a Lewis base Lewis acid interaction. Now this is not a good leaving group in comparison to this. So what happens is that we tend to form, or a rearrangement occurs as follows. We end up forming RCH double bond NH2 plus as an intermediate, and this part is lost. Now this itself is a unstable species, and so in the presence of another LiAlH3 moiety, it undergoes a attack of this hydride on this carbon, and finally the product is RCHNH2, the desired primary amine that is obtained from the reduction of acid amide by lithium aluminum hydride. Now let's take up the second example, that is the reduction of the nitrile, and let's briefly write the mechanism for that also. And here we have a RC triple bond N, and as earlier, this in the presence of lithium aluminum hydride, this polarizes as delta minus delta plus. This H minus hydride attacks this carbon, results in an intermediate RCH double bond N delta minus, and this is then stabilized by the Lewis base Lewis acid interaction. And now there is an internal transfer from this moiety. Another hydride attacks this carbon, and we end up forming RCHH N delta minus ALH2 Li plus, and this undergoes protonation to finally release RCH2NH2, which is the primary amine, and this bond then breaks up. Upon protonation, the nitrogen picks up 2 protons, forming the NH2, while this carbon has already been reduced to CH2. So this is the brief mechanism for the reduction of nitrile. Now the reduction for the RNO2 is fairly complicated, and instead of writing a mechanism for that, we'll just illustrate that what is the possible intermediates that may be forming. The nitroalkane may form a nitroso compound. This nitroso compound can further reduce to end up forming, that is, minus H2O, and this can form a N-substituted hydroxylamine, and this can undergo further reduction to RNH2 plus water. So finally you end up with the product RNH2. From the reduction of RNO2, you end up forming RNH2. Finally, lithium aluminum hydride can also reduce the halide, the alkyl halides, and this is a simple reaction wherein you form the alkane and HX correspondingly. So friends, these are some of the important reduction reactions using lithium aluminum hydride, and most of these reactions are quite important and are useful for your purpose. Let's stop here for a moment.